Hello, my students. Lesson 14, Building Construction Surveys, BIM, Building Information Modeling. Very important, useful, and very interesting topic. Emerging technology for construction layout is combining 3D building information models, short name BIM, robotic total station, laser guidance, and wireless communication to allow field layout or verification of key building component to further increase the accuracy and productivity of construction layout. This figure shows a construction surveyor setting out point. The BIM model for the building is loaded into the total station computer and is visible on the tablet personal computer mounted on the surveyor's rover. The surveyor tapes the personal computer screen to indicate the building component to be located, and the total station direct the rover to the point. The technology allows the surveyors to set and save new points in relation to the design BIM model. The rapid advances in construction surveying technology make it important for surveyors to be committed to continuing education and active involvement with surveying professional society. And what is the BIM? BIM is a process of generating and managing building data during its complete life cycle, from conceptual design through operation of the building. BIM is an integrated workflow that enables architects, engineers, and builders to explore a project digitally before it's built. The creation and use of coordinate, internally consistent, computable information about a building project in BIM is a modern technology and associated set of processes to produce, communicate, and analyze building model. BIM is a digital representation of the complete physical and functional characteristic of a built asset, from design to operation and maintenance. Design include detailed design, analysis, documentation, fabrication, construction logistics, construction, operation and maintenance, and also renovation and conceptual design at the first. BIM model can contain information about budget, schedules, and other very important tasks of the project. And who use Building Information Modeling Workshop? Architect, civil engineers, structural engineers, map system engineers, and builder fabricators. And of course, owners of the project and client, facility manager. The principle is future defines as model federation for the majority of projects. Each designer or subtrade will produce their own model. This model can be then combined or federated to create a single shared model. Interdisciplinary coordination is very important and confirmed in the federated model. Required changes are made in the individual discipline model. On large project discipline, models may be split into multiple smaller models to make file sizes more manageable. Cloud allows different members of cross-functional team, project manager, civil engineer or site manager, accountant, surveyor, and all members of cross-functional team to work on the project in one place. Interaction among the AEC professionals due to BIM without any conflict, because they interact through the BIM model. And who take advantages from BIM? All team of this project. This is, of course, owner of the project, a general contractor, site manager, architect, structural engineers, so all members in the project. With the building information model, engineer can detect all mistakes, clash or collision and make project on site already correctly. BIM stands for Building Information Modeling in addition to 3D CAD model being a special representation of an object. BIM models add certain information one could call a database. Each element is defined: walls, windows, floors, beams, etc. And the model is a parametric result combining all of those elements. 2D plans, sections, and elevation can be generated automatically from any defined position or direction. BIM models may also contain other than structural elements: mechanical, electrical, plumbing installation, and etc., commonly referred to as map. Exchanging data between BIM formats provide to be changing in, and it could cause some problems. We can create native BIM models in two leading formats, namely Revit from Autodesk and ISOSIM from Bentley System. Some as on the standard models, deciding on the level of detail is crucial. While the BIM process in its conception was a tool for the construction, as we are all aware, a significant percentage of projects are concerned with the redevelopment or reconstruction, renovation of exciting building stocks. Throughout the life cycle of a project, 3D laser scanning becomes a key application. And the foundation of any BIM process is the data that the design will be built upon. An appropriate scan to BIM model will provide the basis of this foundation. At 3D, we are highly experienced in the collection and processing of accurate point cloud data. 3D parametric models can be produced directly from the point cloud, typically in Revit format. However, if required, we can deliver the models in Bentley ISOSIM. Based on the model, 2D sheets can be produced at any specified location for plans, sections, elevations. It should be noted that these sheets will not produce the same level of information as would normally be supplied on a typical 2D survey. However, should it be required, we can enhance this information manually if specified at the outset. As with any survey data, the specification is all important. In the BIM environment, due to an almost infinite number of variables available, this becomes critical. We will work with any clients to define specification at the outset. And due to the collaborative nature of BIM process, it may be necessary to consult a number of key stakeholders within the project before producing a definitive specification. And now I would like to show you a collaboration between Civil 3D and Revit from AutoCAD. This is a BIM 360 design. So very interesting video.
Collaboration is key at all stages of a project. Now with BIM 360 Design, you have the ability to access files stored on BIM 360 directly from the Start menu in Civil 3D. Users can now create and access data shortcuts that have been stored in BIM 360 Design also. This allows the data to be accessed by internal and external project members, collaborating and sharing data on the same project from a common data platform. BIM 360 Design gives a user a more efficient way to communicate design problems that arise while in review. When an issue is created, all project members that are affected by the issue receive communication and can take action accordingly. In this example, the reviewing authority has requested that on-site detention be built. Once the design changes have been made, the issue can be closed and then tracked for project progress. Once the design surface is approved, you can publish a surface to BIM 360 from inside of Civil 3D. This provides cloud-based access for the Revit user to utilize the surface in their Revit model. Revit Cloud Work Sharing allows users to co-author Revit models in the cloud, meaning that multiple people can work on the same model at the same time. And with multiple people working on the project, you can track design changes and alternatives by using File Compare in BIM 360. This side-by-side comparison of files helps to visually identify any differences in the project design. The project final design can be communicated to all stakeholders in InfraWorks. The InfraWorks model can be published to BIM 360 and shared to everyone involved in the project. This highly detailed model will help communicate the intent of the project at the conceptual level and when it is fully designed.
The next video, what's new in Civil 3D 2019 in collaboration using BIM.
Collaboration between Civil 3D and Revit is now easier by leveraging BIM 360. Civil 3D allows you to publish a surface that is uploaded to BIM 360 using the Autodesk Desktop connector. Once the surface is uploaded to BIM 360, it can be referenced into Revit using the Link Topography tool. The surface can be revised in Civil 3D and reloaded into BIM 360. Using the Manage Links tool, the topography will be updated within Revit. The surface is geo-referenced within Revit to maintain the project coordinate system. The surface triangles and contours will match the Civil 3D surface exactly. In BIM 360, multiple views are available to preview the surface data. This collaboration process will help streamline cloud-based workflows.
And now how to use AutoCAD Civil 3D.
2013 Introduction. The AutoCAD Civil 3D user interface enhances the standard AutoCAD environment with additional tools for creating and managing civil design information. Standard AutoCAD features, such as the command line and ribbon, work the same way in AutoCAD Civil 3D as they do in AutoCAD. AutoCAD Civil 3D is a vertical solution of AutoCAD. AutoCAD Civil 3D software is a building information modeling (BIM) solution for civil engineering design and documentation. Civil 3D is a software for civil engineers, drafters, designers working on transportation, land development, and water projects. AutoCAD Civil 3D is the most powerful civil engineering and survey software. Civil 3D has the ability to quickly calculate the quantities of materials to be estimated, such as concrete, bricks, cement, etc. with the help of Civil 3D project visualization. Analysis and designing becomes quite easy. User interface. Work area. Above image is the screenshot of the AutoCAD Civil. There are different types of tools and toolbars in this interface. Detail of the user interface toolbars is as follows. 1. Quick access toolbar. 2. Ribbon. 3. Workspace. 4. Tool space window. Tools.
Points are AutoCAD Civil 3D objects that can be displayed in the drawing and manipulated graphically. Point appearance is controlled using point label and point styles. To create point, click Home tab and create ground data panel, surface menu, create surface.
To create surface, click Home tab, create ground data panel, surfaces menu, create surface. Alignments. Alignments are basically the series of coordinates, lines and curves used to represent the centerline of roads, sidewalk, etc. Alignments can also be used to represent the centerline of a channel or stream. To create alignments, click Home tab, Create Design Panel greater than Alignment menu bar, Alignment Creation Tools. Parcels. Any civil 3D projects often involve the division of large pieces of land into smaller properties. You're often required to show the boundaries of your site and the adjoining sites. So these divisions are called parcels. To create parcels, click Home tab, Create Design Panel greater than Parcel menu bar, Parcel Creation Tools.
A profile is used to represent terrain data along a horizontal alignment. Data points are generated wherever the alignment intersects a surface line. The profile view is the Civil 3D grid object that shows the profile data. After you create an alignment, the next step is the road design process is to generate the surface profile. Assembly. Assembly basically represents the typical section and is a starting point for corridor design. To create the assembly, you add subassembly like lines, curves, shoulders, and other cross-section elements. To create profile, click Home tab. Corridor. A corridor model is a three-dimensional representation of the design for a roadway or any transportation design. For creating any corridor, you must have an alignment, a layout profile, and an assembly. To create profile, click Home tab, Create Design Panel, Corridor. Intersection. Here can be described as the area on the road where two roads are crossing each other. When we create corridor on the alignments which are crossing each other, but in actual they do not intersect. To create profile, click Home tab, Create Design Panel, Intersection, menu bar, Create Intersection. Corridor surface. We can create surface from corridor. Actually, corridor surface is our output, and this surface is directly linked to corridor. If make a change in corridor, corridor surface will also change. To create profile, click Corridor tab, Modify Corridor panel, Corridor surface. Sample line are required to calculate section views. Sample lines are created on alignments at a different station. To create sample lines, click Home tab, Profile and Section Views, Sample Line. Section views are the object which we can show in grids that shows all information of section. It's associated with geometry or location of sample lines. If we change in location of sample lines or geometry section, views are changed automatically. To create section views, click on Home tab, Profile and Section Views, Create Section Views. And one more video about collaboration for Civil 3D.
With BIM 360 Design's collaboration for Civil 3D, you can now access your BIM 360 managed drawings directly from the Civil 3D Start menu. Collaboration for Civil 3D allows users to access not only DWG files, but also create and manage data references such as surfaces, alignments, and corridors. It takes a team effort to design any project. With BIM 360, you can add team members to the project and give each member the level of access that is needed to perform their work. Access permissions can be set at the folder level to ensure proper access rights to project data. At the file level, automated file locking ensures data integrity. Collaboration for Civil 3D enables users on the design team to access project design files, data shortcuts, and external references from multiple locations and multiple firms in a controlled cloud-based environment. This gives your company a common data repository that is secure while being outside your company's firewall. BIM 360 allows you to quickly compare different versions of a design file. This allows you to visually compare any changes between file versions and ultimately helps to track the progress of your project. And because versioning is automated, you have the luxury to restore to a previous version at any point of the design process. The review tools within BIM 360 give project stakeholders the ability to create issues and markups. Both issues and markups can be assigned to any project member on the team. The assigned team member can then monitor the review status of the project and take action as needed. BIM 360 Design enables teams to manage the exchange of design data, visualize changes, track project progress, and manage issues in a cloud-based single source of truth, giving you the power to extend all project data to stakeholders for greater project visibility and more informed decision-making.
So I hope it was very interesting for you, and we continue on the next lecture. And now we understand that for civil engineer there is no such thing a little mistake. Why?